Okay, Dr. Matthew J. Trom here again. We are on the third video of trying to solve this dynamics problem of how to locate point P in the reference frame of a driver sitting in an RC car in reference frame G, given that point P can both translate back and forth via capital R and can rotate around the origin here via the angle theta. So we powered through all the way to step 3, which is to write the velocity of point P and the acceleration of point P in the A reference frame. And now we're going to move on to the next step, which is step 4. And step 4, let's get a fresh sheet of paper here. Step 4 is going to be some slightly more intense math. Step 4 is going to be apply the reference frame transfer theorem to find the velocity of P in the G reference frame. So we're going to apply, make sure this is straight, there we go, apply the reference frame transfer theorem to find, let's see, the velocity of point P in the G reference frame. Okay, which this, by the way, is one of the things that we need to find to solve this problem, right? Remember, we're interested in R, there we go, R in the G reference frame, V in the G reference frame, and P in the G reference frame. We've already found R, so this is V. This is the second of the 3 elements that we need. Okay, so the way to do this is to apply this reference frame transfer theorem. So I am going to just remind everybody really quick of what it is. So this is from the first page. Remember, this is the equation that we're going to use to do this transformation. And maybe I'll sit this over here so that we can kind of compare in the frame as I'm doing it. So this is what I'm going to write, but I'm going to write it, instead of using B as my vector, I'm going to use R as my vector to get to P. So let me just write it. So I want the derivative of RP in the G reference frame with respect to T. Now that, if I carry out the derivative, is in fact the velocity of point P in the G reference frame, which is what I'm going for, right? That's my goal, so this is good. And it's going to equal, remember, look over here, the derivative in the A reference frame of this same vector with respect to time, and then plus, we're going to look over here again, omega cross, so we need omega from G to A cross that same vector, RP. Okay. So all I've done here is just like write out this formula, but replace B here with R sub P so that I can get to the velocity of point P in the G reference frame. So I'm going to put this aside now and refocus on this guy. So let's get the frame focused. There we go. Okay, and actually now try to do the underpinning math. Okay, so VP in the G reference frame is equal to dP dt in the A reference frame. What is that? Well, let's remember, this is page, nope, wrong page. Here we go. This is page 2 that we were just working on before, right? So here it is right here, right? dP, let's see, the derivative in the A reference frame with respect to time of RP is this guy right here. So I'm just going to write that, right? So we'll write that. That is R dot I, right? Let's just make sure that that's right. Yep. Okay, R dot I. So that's this term. and then I have to add omega. Well, remember, I, in the very beginning, set up what omega was. So this is the first page, right? And here's what omega actually is. And since I've written this first term in the ijk coordinate system, right? This is I hat. I'm going to use my omega in the k hat direction, right? So that they're pointing both in the a reference frame. So omega is going to be theta dot k hat, and then that is going to be crossed with RP. Well, what's RP? Well, remember, at least in the IJK reference frame, RP is just capital R I hat, which that was the second step we did right here, right? So here's RP, and here's R I hat. So that's where that comes from. Okay. Now, I've not actually done the math. I've just written this out. And now the next step is to crank through the math. So VP in the G reference frame is equal to, no math needed here in this step, right? R dot I hat, that is what it is. But now I've got to deal with this cross product. So what's the cross product of theta k hat cross R I hat? Well, I know at least the magnitude is going to be theta hat R. And then I've got to figure out what to do with k cross I. So remember back in the beginning, I had, this is the first page, this little cheater here. And let's see, k cross I. Okay, so if I start with k hat and I go in the I hat direction, that gets me to j hat, and I'm doing it in the direction of the arrows, this nice counterclockwise direction. And so this is going to end up being j hat, and that is the end result. So let's box this guy. So now I've got the velocity of point P in the G reference frame, expressed just as a series of variables that eventually will work into my equations of motion. So that's the second piece of it. That's the second part that I need to solve. Okay, the third part is a little bit even more mathematically intensive, but we can do it. So step number 5, this is really the last thing that we need to do to get to the equations of motion. So we're going to apply, again, the reference frame transfer theorem to find, in this case, it's going to be the acceleration of point P in the G reference frame. Okay, so to do this, I'm going to just apply that same theorem again. So that same theorem from page 1, here it is right here. And I'm just going to substitute the appropriate variables in. So the first thing that I'm going to do is just write it out so that you can see it written, and then we'll crank through the math. So to find the acceleration of P in the G reference frame, I'm going to take the derivative of VP from the A reference frame in the G reference frame with respect to T, and that's going to be this acceleration of point P in the G reference frame that I'm looking for. And to get to that, I first need, I need to do this term, right? So I need to take the derivative in the A reference frame of something with respect to T. Well, what's that something? It's going to be VP now in the G reference frame. Okay, so I got that term. And then I need to add my omega, that's my rotation from G to A. So that's the rotation between the G reference frame and the A reference frame. And then I need to cross this with my velocity in the G reference frame, which happily I just solved for. So I've got that. Okay, so all I've done now is just write the reference frame transfer theorem, this equation, for the acceleration of point P in the G reference frame. So I've just written the formula. I've not done any of the math other than just writing the formula. Okay, so now we're going to start to crank through some of the math and see if we can get this to resolve into something that we believe. Okay, so A, the acceleration of point P in the G reference frame is, okay, first we got to figure out this term. So what is the derivative of this guy with respect to t? So I'm going to just write it out. So the derivative in the A reference frame with respect to t of this guy, which is this that I've already solved, r dot I hat plus theta dot r j hat. Again, no real math here yet, just substituting things in. And then I'm going to add my omega. Remember from before that omega is theta dot in the k hat direction. And then I'm going to cross that against this the same velocity that I had before. So it's going to be r dot I hat plus theta dot r j hat. Okay, so not yet really done any math. I'm just sort of progressively substituting my way down. Now I'm going to start to do some of the math. We'll actually carry out these derivatives and cross products and see what we get. Okay, so I need to take the derivative of this guy. So I've got the sum of products. So let's see, let's do the derivative of the first term. Well, okay, it's already a product. So I need to do the derivative of the first term times the second term plus the first term times the derivative of the second term. And note that I did this in the A reference frame, right? And so, let's get this zoomed in here, framed up. Okay, focused again. Okay, so you guys remember this from before? What is this? This is the derivative of I with respect to t. And because this derivative was taken in the A reference frame, this is in the A reference frame. This is the reference frame, if we remember back to the original formulation of the problem, the A reference frame is the one that's corresponding to ijk, right? So we talked about this before. This one goes to 0 because the direction of I hat remains unchanged so long as I'm in the A reference frame, which for this derivative I am. So that term goes away. That's pretty neat. Okay, so here we're going to do another product rule. So I'm going to take the derivative of the first term times the second plus, let's see, the derivative of the first term plus the derivative of the second term, there we go, times the first term. Okay, right? Derivative, let me just get this right, derivative of the first term times the second term plus the derivative of the second term times the first term. Right, okay. Now, those both happen to be in the j hat direction, j hat. Now, just like before, right, just like over here, there's actually a whole series of additional terms over here that all go to 0, and I'm not even going to bother writing those terms. Those terms come because I've actually got a product that has 3 components, right? I've got this component, this component, this component. But every single time that I take the derivative of the j hat component, the whole term goes away for the same reason that the derivative of the I hat component goes away. It's because the j hat component in the A reference frame never changes direction. It always stays fixed to the A reference frame. So even if the A reference frame is moving, from the perspective of the little stick figure sitting in that reference frame, this j hat direction remains unchanged, which is, I think, pretty cool. So anyway, that all those extra terms I won't write; those all go away, and so we're just left with this expression. Okay, so I'm going to stop the video here because I'm just about at 15 minutes. We have just done this derivative. I have not even bothered to touch this term yet. I will jump into this term at the start of the next video, and then we should be able to wrap things up. Okay.